Welcome back to another video. My name is Dr. Tarcia Hubert, and in this video I am going to be talking about the negations of conditionals, negations of conjunctions, and the negations of disjunctions. Okay, so if you don't know what a conditional is, a conjunction is, or a disjunction is, then you want to go back and watch one of the videos where I explain what those are, and I'll put the link to those down below in the description just in case you missed those videos. But we're going to actually talk about what it means to negate each of those statements. And we're going to start off with the negation of the conditional, which I have up here, negations of conditionals. And remember, the conditional is P implies Q. You can read it as P implies Q, but that means if P, then Q. So I want to look and see what happens when I negate P implies Q. So what is the negation, or basically the opposite of if P, then Q? So when I negate that, that is the same as P and not Q, alrighty? And I use the equal sign with an extra line to mean that those two statements are equivalent. So the negation of if P then Q is P and not Q. So the negation of a conditional actually becomes a conjunction. Remember, conjunction is the and statement when you combine two statements with the and. And so this is how you would negate if P then Q. And so let's look at an example to see how we would use that. For this first example, we want to write the negation of if too much homework is given, then the class should not be taken. Okay, some of y'all might feel like that, right? If that class has too much homework, I'm not taking it. You probably would have been in my class if you felt that way, because my class has a lot of homework. But anyway, that's just off on a side note. But here's the statement: if too much homework is given, then the class should not be taken. So our statement is if too much homework is given, so P, a class should not be taken. So it will be P implies not Q. So that's the statement that we have. Because remember, we always take the positive side of that statement and let that represent what the statement equals. So instead of letting Q be a class should not be taken, Q is a class should be taken. And so our statement is actually P implies not Q. Because it said a class should not be taken, we take the negation of Q. All right, so now we want to actually negate this statement. So in order to negate this statement, remember the negation of the conditional is the first statement and the negation of the second statement. Well, the second statement is already negated, so we would negate it again, and it would get us back to the original statement of P. So the negation of P implies not Q would be P and Q. So the negation of our statement, if too much homework is given, a class should not be taken, would actually be too much homework is given and a class should be taken. All right, too much homework is given and the class should be taken. That would be the negation of our original statement. Now we're going to look at the negation of the conjunction and the disjunction. And these are actually called De Morgan's laws. So De Morgan's laws actually tell you how to take the negation of these. All right, so this is how the negation of the conjunction works. So if I want to negate P and Q, all right, so kind of think of that negation being like a negative sign in your typical algebra class. If you're familiar with the negative sign and what you do with it when it's outside of the parentheses, you actually distribute it inside the parentheses and it changes the sign of everything inside the parentheses. So it's really, really similar. It's like you're going to distribute that negation inside and it's going to change everything that's inside those parentheses. So this P becomes a not P. Now when you negate, so in algebra, when you negate a plus sign, it becomes a negative. So when you negate the and sign, it actually becomes an or, and then you negate the Q. So when you negate P and Q, it becomes not P or not Q. Okay. So again, if you're familiar with your traditional algebra, think of that as like a negative sign that you're distributing inside, and you're changing or you're negating everything that's inside those parentheses. So if you wanted to negate P or Q, which is the disjunction, then you would do the same thing. Distribute that negation inside the parentheses, and everything inside the parentheses becomes negated. So that P becomes not P, that or negates to an and then that Q becomes not Q. So the negation of P or Q is not P and not Q. So I want to look at one of the De Morgan's laws, and we want to look at the truth table for it, just so you can see that the statements are actually equivalent. The negations are equivalent. So we're going to look at the negation of the conjunction. So I'm going to start my truth table with P and Q, because it only involves two simple statements. So P and Q, and remember, you start off your truth table with true, true, false, false, and true, false, true, false. And now I want to look at P and Q. So remember, the conjunction is true when they are both true. So this would only be true here, and then all of the rest would be false. Okay, now I want to look at the value of the negation of P and Q. And so remember, in the negation, you just take true and switch it to false, and false and switch it to true. So it will be false, true, true, true. Okay, so that would be the negation of P and Q. That's the truth values of it, right? Okay, so now remember that the negation we said was equivalent to not P or not Q. So now I want to look at the truth values of not P or not Q. But in order to do that, I need to do a not P and a not Q column. So not P will be all the opposites of P, which is false, false, true, true. And not Q will be all the opposites of the Q column, which is false, true, false, true. So now my statement that is supposed to be equivalent to, according to De Morgan's law, to not P and Q is not P or not Q. So for this one, I'm looking at these two columns and I'm combining them with the word or. And remember that an or statement is true when at least one of them is true, okay? So here, neither one is true, that will be false. Here, one of them is true, that will be true. Here, one of them is true, so that would be true. And here, they are both true, so that would also be true. So now I'm looking to see, do these two columns have the same truth values? And you can see that they do. False, true, 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 false, true, true, true. And this is just a way to prove that those statements are actually the same. So not P and Q is actually equivalent to not P or not Q. And that's, again, De Morgan's law. And I just wanted to show you the truth table to show you that those are actually the same. And we could go through and do that same thing for the negation of the disjunction, and you will get the same exact result. You will see that the negation of P or Q is the same as not P and not Q. Okay, so now let's look at some examples. For example 2, we want to write a statement that is equivalent to, it is not true that Atlanta and California are cities. Okay, so we have two simple statements. Our first one is Atlanta is a city. And our second one is California is a city. And so we want to write an equivalent statement to, it is not true that Atlanta and California are cities. So we need to take that and represent it in symbolic form. So it is not true means the negation. It is not true that Atlanta and California are cities. So that would be P and Q. So it is not true that P and Q, it is not true that Atlanta and California are cities. So we want to write a statement that's equivalent to that. And so now we know that by De Morgan's laws, if we want to distribute that, and in a sense, it's not really distribution, but in the sense, if we want to distribute that negation in there, then this gives us not P or not Q. Okay, so that becomes not P or not Q. And so then an equivalent statement would be Atlanta is not a city or California is not a city. Okay, so the equivalent statement again would be Atlanta is not a city or California is not a city. And so that's how you would use De Morgan's law for the negation of the conjunction in this example. Okay, let's do some more. So example 3, we want to write the negation for the following statement. So this one is going to have two parts to it. So the first part is all students do laundry on the weekends and I do not. Alrighty, so in this case, I need to identify my P and my Q. So my P would be all students do laundry on the weekend. my Q would be I do not do laundry on the weekend. All right, so that's my P and Q. P is all students do laundry on the weekend, and Q is I do not do laundry on the weekend. All right, I don't remember when I did laundry when I was a student. That was so long ago. Anywho, I do laundry on the weekends now. And so we want to, actually, since this is the negation, let me change this. This Q should actually be I do laundry on the weekend. Remember, we always go with the positive. So let me change that. I do laundry on the weekend. All right. So now we want to write our statement in symbolic form. And our statement was all students do laundry on the weekend and I do not. So our statement would be P and not Q, because it said I do not do laundry on the weekend. Okay, so P and not Q is our statement. We want to write an equivalent statement to the negation of that. So if we negate this, the negation of P and not Q would be. So now you want to think, and this is why it's good, instead of just remembering the formula for De Morgan's law, it's good to actually know what you're doing, because now this is different. This doesn't say just P and Q, it says P and not Q. But if you actually know that it's like you're distributing that negation in there, you're negating everything inside the parentheses, then you would know that this will be equivalent to not P, or the negation of not Q will be Q. Okay, so the double negation will take you back to the original statement. So the equivalence to the negation of P and not Q would be not P or Q. So that means our equivalent statement would be, okay, so here's something else we need to talk about. The negation of all is some and not. And then the negation of some is no or none. Alrighty, so these are those quantified statements we talked about a while back, but I don't think we actually talked about how you negate those. So when you, or maybe we did, I can't remember, but I'm reminding you if we did. So the negation of all would be some or not, and then the negation of some will be no or none. All right, so I said that because in order to negate P, we would change all students to some students. All right, we will change it to some students do not. So the negation of not P would be some students do not do laundry on the weekend, or I do laundry on the weekend. So the negation of our original statement would be some students do not do laundry on the weekend, or I do laundry on the weekend. So that's how you would negate that. All right, let's look at the second part. So part B is some college professors are entertaining lecturers or I'm bored. Okay, some college lecturers are entertaining lecturers or I'm bored. So my P would actually be some college professors are entertaining lecturers, and then Q would be I'm bored. So our statement in symbolic form would be P or Q. So some college professors are entertaining lecturers or I'm bored. All right, and we want to negate that. So if we negate P or Q, now that one is exactly as the De Morgan's law, so that's not P and not Q. And so we have to negate P and we have to negate Q. However, since we're negating some, I just erased it. But remember, I just said that the negation of some is no or none. And so when we negate P, it will be no college professors are entertaining lecturers and I'm not bored. So again, the negation of our original statement will be no college professors are entertaining lecturers and I'm not bored. All right, so that's how you would negate those. That is examples of using De Morgan's law to negate the conjunction and the disjunction. For this last example, we want to write an equivalent statement to, if it rains, I do not go outdoors and I study. Okay, if it rains, I do not go outdoors and I study. So this one actually has 3 statements. The first statement is, it rains. The second statement is, I go outdoors. And the third statement is, or I study. So using those 3 statements, if I take the original statement and write it in symbolic form, it's an if-then statement. So I'm going to have the arrow. And the first part is, if I go outdoors. No, the first part is, if it rains. So P. Then I do not go outdoors and I study. So I do not go outdoors. So it'll be not Q. And so the conjunction symbol, I study, R. So since those are together with the comma, so remember the placement of the comma is important. So since it's a comma after the if it rains, that means that's the first part, and that means what comes after that comma is grouped together for the second part. So if it rains, then I do not go outdoors and I study. This will be the symbolic form of that. Now we want to write an equivalent statement to that statement. Now, we have to not only use De Morgan's law, but we also have to use the fact that we know that the conditional is equivalent to the contrapositive. So we talked about this in the last video, that the conditional is equivalent to the contrapositive. And so remember, that is P implies Q is equivalent to not Q implies not P. So that's the contrapositive. Not Q implies not P. So basically, remember, you switch and you negate. All right. So that means if I want an equivalent statement to this, I will switch both of those statements and I would negate them. So I will take the negation of not Q and R, put it first, and then I will take the negation of P. So this will be the contrapositive of that statement. Okay. But now I have to negate this conjunction. So now this is where De Morgan's law comes in, because now I have to negate, because of this negation outside the parentheses, I have to negate this conjunction. And remember, that's just like distributing that negation in. So you would change the sign of the Q. If you negate this in here, you would change that, so that will become back the original Q. If you negate the and, that would be or, and then you would negate R. And so this will be an equivalent statement to our original statement, if P, then not Q and R. So the equivalent statement would actually say, if I go outdoors or I do not study, then it is not raining. Okay. So again, the equivalent statement would be, if I go outdoors or I do not study, then it is not raining. Alrighty, so that's how you would basically use a lot of the stuff that we talked about before, the fact that the conditional and the contrapositive is the same, and then that's how you would use the De Morgan's law to actually negate the conjunction to actually come up with an equivalent statement. Okay, so again, all of this is logic. It may seem useless now, but there is definitely a point where you can use this and you will use this. Depending on what field you're going into. I know you may be wondering, when and where am I going to use this, but this is definitely useful for attorneys, because you have to have deductive reasoning, you have to have that logic to analyze cases, but there are other areas in which you use logic as well. Logic is used a lot in computer science, so in programming, if you're interested in creating games or apps, you use a lot of logic in those as well. So there is a point of all of this, okay? So I don't want you to be like, oh, this is pointless. There's a point to it. It just really depends on what you want to do, if you'll see it a lot or not, okay? So thanks for tuning in, and I will see you all in the next video.